Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 62. In today's lesson, we're going to be talking about pattern matching. I've already got us a little project set up here. So what we have here is, we'll come back to the main method. So we have a class here of customer. They have a name, a discount rate, and a toString. And toString just shows the two values. So the idea here is that we'll have new customers, which they just have the default, and then you have years you've been a customer, I guess, something like that, and you get a discount based on that. So something that changes. May not need that. I don't know. I actually haven't thought through it all the way yet, but we're going to play around with pattern matching though, and I needed some kind of tree here, and customer, new customer, or returning customer works for that. So then up here, we created a list of new customers. And for each one, we're going to do this. So we say customer, if the customer is a returning customer. Then we set the customer. We have to cast it, and we can output it. In doing so, that gets us what we expect. Then I put the years partnered at the end there for ones that are returning customers. So there we go. So 0, 0, and then there's the one with the discount rates. So what we're going to be talking about today is pattern matching, and it's ways to clean up this. And it even gives us a tip here, use pattern matching. So we actually have a quick fix for that. And that was all it did. So let's undo that. So how you do that is you do returning customer. Then you can get rid of this line. And at this point, it'll do the exact same thing. So what that does is it says check if the customer is a returning customer and set them to this value. And that's the very, very start of pattern matching. So it's a way to simplify a common pattern. So you'll see, or if you're doing a lot with objects and object trees and interfaces and stuff, you run into checking is it something and doing something based on that somewhat frequently. Notice we also don't have a cast. We let the compiler handle it, so that's also nice as well. If we messed it up here, we'll still get an error here, but now it's a compile error. So that prevents it from being a runtime. The other way would have been runtime, so let's go back. If we put a not here, now everything's fine until we run it. So that's a runtime error. It becomes a compile time. Whoops. It becomes a compile time error though when we mess it up here. And those are easier to catch because they happen when you try to build rather than when you're trying to use it later. So the idea with pattern matching is it lets you check the structure and you can get out values at the same time. So that's the basis of where we're going to be looking at today. So the most common way you see it is this, some kind of, let's remove the not, some kind of if check or something you're checking is someone of that type, and it's handling the cast, it's checking doing the type check and assigning the variable all by itself. Another time you'll see it is with or switch statements. So switch statements, you have to do this with I think it was C#7, maybe it might have been 8, 7 or 8. And earlier than that, you couldn't actually do this, but with that you can. So let's do another example. Let's do a object value 10, something like this. So what I did here is we'll do a switch, and we'll switch on the value. Case int I, case, not cast, int I. And we'll do console.write line integer break. So there we'll do some math there. String s string s. We'll do one more. Double D. Default. Something like that. All right. So there. This will get us something as well. So there, we think it's an integer, and that is correct. So we are checking what type this object is, and it's that. We had a 0. Now we should get a double. We make it a string. We get a string. With all that, we're doing the if checks for different variable types, and once in a while you'll run into that, and it can be useful. Let's make it a character. We'll do a character there, and on top. So once in a while you'll run into something like that, and you'll need to do a bunch of checks, and you can do that with a switch statement now. So there's two uses of pattern matching though. So what it's doing, it's not matching the data particularly, it's checking what pattern is the data in. Here the patterns, is it string, a double, an integer, or something else. So another way you can see that is with the switch expression. So I think I've used these before, but we'll use them again here. So we'll say, here, let's do it the original way first. Here, let's do this. Let's comment out this temporarily. Okay, Control C. Now let's talk pattern matching with a switch expression. So we'll do a let's do an int result. Do it like this. So switch option. Now it's in quotes. Now we'll come back to that. I will say let's do string. Probably character is actually fine, but we'll leave it as string for the moment just to show we can do this with strings. Probably actually character is fine for what I'm about to do. So let's just do a case. Let's do result equals -2. Get us a negative number, break. Throw new exception. All right. So here, and it's even going to give us the hint there that we can do that. So we'll do CW. We'll just print out result. So let's see what result is here. So we'll say for plus, we know it's going to be 3. So however we got to 3, we would read it from console write line maybe or something. Minus. Get a negative number here. So there's a switch statement. So we can make that a switch expression. I expect, yeah, that's what that's going to actually offer. But let's do it ourselves for now, but it'll give us the right thing as well. Control K, Control C. So that's a switch statement. So here's using pattern matching as a switch expression. I got rid of opt. There we go. Switch. And the syntax for this is something like this. So we return a, I'm saying a plus b, 1 plus 2. I was originally going to get this from the command line, but oh, these are commas. And default case is just an underscore. Throw new exception. Here it is. Okay. So if we run this now, with minus we'll get -1, with plus we'll get 3. There we go. So these are functionally equivalent. The top one's using traditional switch statement though, so basically checking each thing. This one's using pattern matching, so it says whatever pattern this is, apply this action. So if it's a plus, do this. If it's a minus, do this. Otherwise, throw an exception. So that pattern can be pretty useful. The underscore is the default case. That means matches anything that wasn't already matched. So the thing with this is it's an expression. So a statement's just something happened. This is a statement. An expression returns a value. So here we're saying switch on whatever type of option is and return whatever this is, or throw an exception. In doing that, you can make a calculator with that or something pretty easily. We could extract this out to a method very quickly. Let's do that. Let's extract it. Let's do we'll just do public static calculate. We'll do int a. Here's where my a and b came in. String op. So we'll do return op switch. We'll just copy this. I need to say this is an int. And there we go. Now we can make this a and b. There. All right, so now we can do result equals calculate equals calculate 1, 2. And option. Now we can make that go away. So yeah, there's this let's grab all this just a second. Yeah, there's just a simple calculator. So it's been a while since we've actually done a calculator, but yeah, there. But this wasn't how we did it originally, but this is one thing you could have done. So to add a new case, all you have to do would be add that case and the add. And you'd want to do a little more with b, because b in this case to make sure it's not 0, but you could do something like that, and you could have that as a we'll do static int divide int a b that'd be a little trickier actually. I was going to try to make it do something different here, but I guess we would get I guess throwing the divide by zero exception is actually what I'm about to do here anyway, so I don't guess that's actually needed. But what you would do here would be just return a divided by b, and then say here if b equals 0, throw new divide by zero exception. So that's going to be actually the same thing here, and here it's saying it's never used. What we do there is pass it here, and because all we need, the only requirements that we return a value, this should be fine. And there, fine with the switches statement. So here, if we do a division here instead, suddenly it works. We don't have to do a lot of extra changes, but you can swap out it or your expression here. It's perfectly fine for it to be a method. So there's another use of pattern matching, though, is switch expressions. And I personally find them, I like seeing them. I'd rather see this than the switch statements most of the time, but that's a matter of preference. I don't think there's a major difference between them. I just like the format, and it takes up less space, and you don't have to remember break. No, I think it would be pretty easy to forget the break. I actually don't know that I've ever done that actually, but I could see it being very possible. And if you wrote a lot of them, it would. A lot of times, if you're writing switch statements, there's a good chance you should break it out anyway. But for a small one like this, it's probably okay. So there's just another example. Let's do another example. Let's say there is a, I'm trying to think something to do with pattern, with relations. So like less than or greater than. I guess grades are maybe the most common. Let's do that. Let's say we have an int, maybe score equals, I don't know, let's say let's say 85. So here we can do it as a function. Get letter grade, passing in score. All right, so let's do this method. I said function. Let's do this method. Public static car get letter grade score, int score. I guess this should be a string. So let's do this. So we'll have return score switch. So greater than or equal to 93. This is just what the grade system. This is just a grade system I've seen, but I'll write it out here first, and then we'll explain what's happening. Hopefully, it's pretty self-explanatory. I think it's 87. Yeah, we'll do it. I don't know if these are the exact values I would have seen, but I'll use this. We'll do the same thing. Should have just done full letter grades, probably. I think we got the point. Something like that. To be completely honest, I don't think I was pretty much an A student, so I'm never actually worried about any of that. But I think that was the grading scale we used back at high school, back in high school. So something like that. So there's showing relationship. So here, if if the score is greater than 93, it's an A, and then it just passes down the list. So you could do this with a bunch of if statements. You could do it with a switch statement. I think this is a lot more expressive of what you're trying to do, though. If the score is greater than 93, it's an A. If it's greater than or equal to 90, B. It just keeps working its way down until you get your grade. So here, whatever we say, 85 should be a B, and it is. Let's pick another one. Let's say 63. So we should get an F for that, and we do. So there we go. So there's just another little example, and we could be passing this into the program if we needed to. Is we could do this if we get the value string arg. Here we'll do score equals arg at 0, and we'll do dot parse. All right. Oh, arg dot parse string dot int dot parse arg. There we go. Yeah, having trouble thinking of that. So we could do that and pass it in as 87. I thought that was wrong. Args at 0. There we go. There. So we could do that and we could be passing it in, but there's just a letter grade, and that's showing relational pattern matching. So we're matching the pattern of the data. So the idea here is threshold. So you have some threshold before you drop to the next level and next level. And I personally like seeing this one as well. I'd rather see this than quite a much larger set of if statements. Yeah, I probably wouldn't do that, but you could actually make that an expression here as well. Seeing if it would let me switch it to an if. Yeah, not easily. We'll leave it at that, but you could imagine what the if statement would look like there if you did it as an if instead. So another one, we've actually seen this one before. So let's do another example. Here's another use of pattern matching. So this one, let's say we have we'll use that same value we're getting it here. We'll say int value equals int parse args at 0. You would want to do more actual validation there, but here if value is greater than 0 and then value is less than 10, we'll do CW single digit else CW multiple digits. So this is the old way to do it. That's multiple digits. That's single digit. So this was the old way to do it. So each time you have to do the value on both sides. With pattern matching, you don't have to do that. You can do this instead. So we can say value is greater than 0 and less than 10. And I actually remember one of my programming instructors saying that they're basically that basically wanting to do a way like this, and it just wasn't possible at the time. That it wasn't supported. So you didn't have to specify value on both sides. You could understand it, and it just wasn't something that was done at the time. So that's one thing that came about as part of pattern matching as well. So you can combine conditions. And one like this, I find it very useful. I still do though if it's something bigger, like if you have more cases or longer cases. Usually, I'd go ahead and pull that out to a method, maybe a local method or something to pull it out a little bit and be able to better understand the logic. Usually, if it's much bigger than this, it's probably going to get hard to understand quickly. All right, so there's another use of pattern matching. So another use of pattern matching, so we can match an object structure. I'm trying to think if I could do this with my data down here. I think I can. Yeah, let's do this. I was trying to think if I wanted to use this. I think I can, but I, I think I could probably think of a better example if I gave it a minute. So let's uncomment this though, and we'll use this, but I might can think of a better example while I'm doing this. So let's do this. So if now we need to get to customer. We'll do it in for each again. For each or customer in customers. We'll say if C is sorry, if customer is name equals, let's do discount rate. Let's do discount rate equals, it's not equals, it's a colon. So we'll say if the discount rate is, better check what I put up there, 0.08. I think this will work. So if it's this rate, CW long-term customer. Something like that. Let's see if that works. I'm not completely sure it will, but I think it should. Long-term customer, yeah. We only got one of them though. If we put the else condition here, your customer. We should see 3 of them and 1 long-term. Let's make sure we do, and we do. So what that's doing is it's saying we're matching the pattern there. That's a bad example because I'd want to say maybe if it's greater than 5, so greater than 5 years or something. But with our structure down here, we can't use years partnered because only returning customers does it. If we get a new customer, it would break. We can use the discount rate though because it's available and everything. There's one example. Let's do a. Here, I think I've got a better example. Let's do a better example. Let's comment this out. Let's try this one. So let's say we're doing some kind of, I don't know, maybe a graph work or something. So let's do a class here. Class point. So public int x get set, public int y get set, something like that. So let's do some work here. So could we'll do a list of points add new point. Let's make that a x, y, x, y. We'll make them immutable. There. There's just a point now, so now we need to pass that in. We'll do a 0.0 or 0, 0. Let's do this. We'll do a 1, 1, -1, -1. Get one in all 4 quadrants. Right there. And I guess we could have put this in the values. Could have done this, I think. Right. Yeah. We'll do that. Add a comma here. We'll select this. Control D, Control D, Control D. Comma. There we go. And I'll put these on a new line like this. There we go. A little more readable. You can tell that's a newer one just by the fact that that's not the one I go to. I still do the old add route. So that's at least it's newer than my time in C# when I started C#. So now let's do a for loop here for each. Let's do some more pattern matching here. P in points. So if P is x colon 0, y colon 0, CW origin. We can do that a couple times. So I've used exactly before. So here would be the example here. We would have some kind of year. We might want like some year cutoff. So here, let's do greater than or equal to 0, quadrant 1, this. Hopefully I get my quadrants right. So quadrant 2, so if we have a grid of, I don't have a good way to draw it, but we have a grid of like 1, 2, 3, 4. Quadrant 2 is down here, so it's negative on the y, positive on the x. The remaining ones are negative on the x. And positive and negative. Let me make sure that's right. So quadrant 3 is here, so negative x and negative y. So no, got them backwards. All right. So quadrant 1, quadrant 2, quadrant 3, everything negative, and quadrant 4, y is positive. Okay, there we go. So yes, I would have got them wrong at first. So we'll see if we get the value we expect here. I think we will. 1, 4, 2, 1. Does that match our points? The 1, 1 is in quadrant 1, negative 1. So x is negative, so it's over here. Positive 4, good. Quadrant, or so x is positive, negative, quadrant 2, good, and quadrant 3, yep. So there we go. So there's just a very complex, I say very complex, a complex one here with multiple values. So here we're doing relationship there. So we're saying it's greater than that number, you're good. Let's see. Yes, there's some here. What happens if it's on the line? So if this is an actual example, we might need to do just a little more work here. So something like this. There, it doesn't. It's not now on the line, so maybe that's incorrect. I actually have to think on. That's interesting. I actually have to think on what's supposed to happen there. I actually don't know right offhand if it's on the line, if it's in the quadrant or not. It's just dividing the quadrant, but there's us another example. So that's using pattern matching here to match the points to different conditions of them. Let's do a let's do then another example. So this example is showing they're just using what we've learned. So this is getting ready for our next topic, which is probably going to be we're probably going to move into another data structure next, and the data structure is called trees. So this is classifying nodes in a binary tree. The idea of a binary tree is let's just do a new file here. Test.text. So we'd have something like here. So trees in computer science is something like this, and this is not a great example because we need more space. So we actually need one more. Here, I'm going to make a full tree just because I should, but yeah, it should probably be a 3 just to follow the pattern I'm doing. Notice that's not going to work. We need one more space here. So we'll do 2 spaces there. Something like that. There. Oh, good. And that's good enough for reading purposes, but that I feel like I could get that nicer. But this is a tree in computer science and data structure. So you have a root, which is at the top, and the tree works its way down. So completely opposite of trees. There's a meme that there's a tree growing upside down. I think it's in Australia, and there's an actual computer science tree, but the root's at the top and it works its way down to the top here, and then these are leaves here. Each one's called a node, and a node for a binary tree, a node can only have 2 values on the side. There's other trees of different number of branches, but a binary tree can only have 2, so it's considered a full node if there's 2 values. So this would be a tree, and these 3 nodes 0, 1, and 2 are all full. Nodes 3, 4, and 5, and 6 are called leaves, so they are not full. So let's make that. So we'll have let's come down here and make a new class. We'll have a class of node. I just majorly misspelled that. Public node left get set. Public node right get set. So those are just representing the left and right sides. So what we could do here, we could have a I'm trying to think how I best to do this. So we could have a class tree, and it has public. Now let's not do that. No. We'll do it with just a node here. So let's do it. Let's do a class or a method here. We'll do static. No, not it here. One level out. Public static string classify. We'll classify nodes. In switch. So now if it's a left is null, right, null, leaf, left, not null, right, not null, full node, else it's a single child. So there's a little method in class. Let's see. Let's make their example here. Guess we also need public string data get set. There we go. We'll require that one. And we can get rid of set then. We'll just do toString public override toString return data. Something like that. So now let's make that tree. So we'll do public. We'll do node binary tree equals new one. So there. Put it as a string. We'll make it a int. There we go. So data is not actually going to come into play here, but we'll see what it does. So so to add a new node, we would do binary tree the left. I wouldn't need. I'm going to run out of time actually building this, so here we'll go ahead and do it, but we'll equals new node 2. Let's do it like this. Node left child equal new node left child dot left equals new node 4 right 0. Oh, we're backwards. 0 1 3 left child dot right 4 something like this would actually work. So here, let's grab these. Notice it's giving us a hint there. Right child 2 5 6. So let's look at that hint. So what is it saying? Object initialization can be simplified. We can do that. Now it's giving us another hint. New expression can be simplified. Yeah, we can accept that. There we go. There's a tree. So let's do this. Let's change the toString here. We'll do it like this. Hmm. Here, let's see. It's data. Left. So we should be expecting some empty spots for nulls there. So we'll do that. So let's do CW binary tree. Let's see what we get. Build failed. Syntax error. Syntax error. Forgot my comma. Again, that's a compile time error rather than a build time error. And not a good example, but 0, 1, 3, 4, 2, 5, 6. Does that make sense? So 0, 1, 3, 4, 2, 5, 6. So there we go. We were able to read it out in some order. And we'll find that there's different types of orders. There's 3 orders you can read a binary tree in. What we've just done is one of them. We'll look at the other 2 next time. Notice there's some here. 3 here's it's followed by 2 blanks. That means it has no children. Left and right's both empty. 4 left and right's empty. 5 left and right's empty. 6 and right's empty. So that's a binary tree though, and we've just represented it here in one method to read it. So what we did is we went down and around and up and down and back. So the way I would think about it is we went around along the outside. So we hit this one, we hit this one, we hit this one, went back up. Back here we hit this one. Then we went back around and around, back at a 2, then we hit the 2, we hit the 5, around, and then we hit the 6. That's one method of reading though, so maybe useful to keep in mind because we might be talking about it next lesson, or maybe might be one more lesson, so it might be 2 lessons ahead, but there's just a little adjustment. So I think that's going to be where we want to. I think that's good enough for the day. I think we've hit a lot of topics and we've added just a little bit here at the end of upcoming topic. So that was pattern matching. So pattern matching, I think you could argue is never required. I think everything I've done today, I think I've actually showed we can do it some other way. Like this, we could do it. We could check customer and then we can check if the customer has discount rate, and then if the discount rate's over something, or we could do all these checks another way if we needed to. I think this is a good example though of how a lot of times it can make it a lot easier to read. This switch statement is a lot easier than this switch expression. Same thing here. I think this is pretty expressive and tells you exactly what you're looking for. And this was very nice. If you've ever done any kind of graph problems, there's a challenge called Advent of Code in December each year, or last many years. If you've done a graph problem, that can really help there because it's easy to understand. It maps with what you're trying to do. Finally, we touched here on upcoming algorithm and data structures we're going to look into very soon. I think that's all we're going to cover today, though. I actually feel like this was a lot of, I don't know where that's come from. A lot of not really, I wouldn't say there's anything useful here, but I won't say it, not that it's useful, nothing required here. Let's say that. Nothing here we've done today is required. You can do it another way. I think it makes stuff easier, and once in a while, like this switch, being able to switch on the types like this, once in a while you can find stuff like that to be interesting and exactly what you need in some cases, and other cases maybe not. But we'll go ahead and leave it with there. So thanks for watching, and have a wonderful rest of your day.